Welcome to the subject software engineering. Today we shall begin with with this session we shall begin with new chapter, that is modeling component level design. Today we will introduce ourselves to this chapter. Point number 1. Component level design occurs after the first iteration of architectural design has been completed. Okay, student, that means what? The component level design, okay, can be taken up only after first iteration of architectural design has been completed. Students, there will be many iterations when you go in for development of a system, software system. So after the first iteration of architectural design has been completed, you can take up component level design. Point number 2. At this stage, the overall data and program structure of the software has been established. Okay, when you reach this component level design, that means overall data and program structure, which is the basic component of any software, have been established or have been finalized. Point number 3. The intent is to translate the design model into operational software. So students, in this component design, our basic objective is to convert the design model that has been developed into an operational or functional software. Point number 4. The level of abstraction of existing design model is relatively high, and the abstraction level of operational program is low, and this translation is challenging. Students, when you develop a design model, okay, the level of abstraction is always high because you have to take into consideration total system, whereas when it comes to operational program, you should work at minute details. That is the abstraction at operational program level is very low, and when you want to translate this higher level abstraction into lower level abstraction, it is more challenging, or you have to put in more efforts and intelligence. Point number 5. When the design model is translated into source code, we must follow a set of design principles that not only perform the translation but also do not introduce bugs to start with. Students, in the component level design, when you are transforming this design model into a source code, you must see that when you translate, the bugs or the errors are not introduced. Otherwise, these bugs or errors that will cause lot of headache and will take up most of the time. Point number 6. It is possible to represent the component level design using programming languages. Point number 7. The program is created using the architectural design model as guide. So students, okay, we can represent component level design using a higher level programming language, and the program thus created can be used, okay, as a guide, okay, for the architectural design. Point number 8. An alternative approach is to represent component level design using some intermediate, that is graphical, tabular, or text based representation that can be easily translated into source code. Students, one can adopt one another alternative approach, that is component level design can be, okay, carried out with intermediate stage such as going for graphical, tabular, or text based representation. With this representation, it is very easy to develop the source code. Point number 9. Regardless of the mechanism that is used to represent the component level design, the data structures, interfaces, and algorithms defined should conform to a variety of well established design guidelines. that help us to avoid errors as the procedural design evolves. Students, whatever is the way, okay, you are going to represent the component level design, the data structures, interfaces that is developed, algorithms, okay, should conform to the design guidelines, okay, so that we will see that errors do not occur when you develop procedural designs. Point number 10. In simple terms, the component level design encompasses a sequence of tasks that slowly reduces the level of abstraction with which software is represented. Students, in simple terms, we can say that component level design will include every step or task, okay, that will reduce the level of abstraction when you want to develop the software. How it is reduced? At the design level, abstraction is high. At the operational level, design, okay, abstraction is at very low level. Point number 11. Component level design ultimately depicts the software at a level that is close to the code. Students, you very well know, okay, when you go in for component level design, basically you are developing each module independently and writing a code for that. That is why component level design is very close to the source code, because every instructions or every step is clearly mentioned. Point number 12. The component level design is important because it represents the software in a way that allows you to review the details of the design for correctness and consistency with the earlier design representation. Students, when you go in for component level design, okay, it is possible for a software developer to represent the software in a way which will allow us to review or check. So whatever software we have developed is right or wrong, whatever program is correct or no, that is possible. Point number 13. It provides means for assessing whether data structures, interfaces, and algorithms will work well. Students, componental design will help us in many ways. Okay, how does it going to help? It will help us to assess the data structure, the way we store the data, the interfaces, that is how the two modules are connected, okay, or how the two modules interchange the data, and the algorithms, that is how the process takes place, okay, whether all these three components, that is data structure, interfaces and algorithms, will work well or no. That is what is identified in component level design. Students, today we introduce ourselves to new concept, that is modeling component level design. Okay, please write this in your notebook. Thank you.